So previously we talked about this concept of non-purgeable organic carbon, right? And we said that MPOC is really what our instrument measures. However, along with this, if I really want a full story, is the purgeable piece as well as the non-purgeable piece. And that's what we call total organic carbon. And then total organic carbon mixed with inorganic carbon will give me total carbon from the sample. So this is the breakdown, once again, of the different types of carbon that might be in my sample out there. But once more, the TOC analyzer actually does not measure both NPOC and POC. It measures NPOC only. That is just what we do. That's how we measure it. That's how it's always done, unless we're told otherwise. So this is assumed. My NPOC is what we are reporting on the TOC instrument. And once more, the purgeable piece is less than 1% on average. So that's why we just don't bother with it unless we absolutely have to. So why should we do it, right? Where on earth would I find a TOC analyzer? Why would I be using a TOC analyzer? What types of samples would I be put onto a TOC analyzer? And here's kind of the first assortment of just different things that could be done, right? It's not the only thing that can be done. It's what could be done on the instrument. And if you're working for an environmental laboratory, and you are focused on soil or you're focused on water, where water's the main carrier here, then you probably will have to be acquainted with a TOC analyzer or a TOC instrument. So if you take a look under box number 1, it says environmental analysis. 1.1 is drinking water. Okay, that's very important for these water companies. So let's say that I work for Cape Fear Public Utility Authority, CFPUA. They are the people in charge of giving you your drinking water through your faucet every day. Well, they want to make sure that that drinking water is clean. And one of the ways that they do that is they can run a portion of their water on a TOC analyzer and record the number. And that number is going to tell them if it's clean or not. That's what all this boils down to, all right? You should not have organic material left in your drinking water. Bottom line, you might have a little bit, but, if we're talking about sediments and sludges and we're talking about bacteria and all of this other crap that might be in a drinking water sample, that's stuff that you don't want. So they're going to have to run their drinking water on a TOC analyzer to get a number as just kind of a field goal, right? Or a goalpost. This is a number that we should be below. And if we're over this number, then we need to figure out why we're over that number, and that requires more testing and more different types of equipment. But bottom line, if it's below this value, then we can feel pretty good about it. Wastewater is also included in a company like CFPUA. So a lot of times, if they are generating some waste, then that is going to be recycled into wastewater, and that goes back down into maybe the river, Cape Fear River, and out it goes, right? Okay, well, one of the reasons here is they cannot be dumping anything too dirty back into the river. So they basically suck their water up from the river, they process it, and then they send it back into the river after they get it finished. Well, they are pulling water from the river. They'll figure out how clean it is, and they'll make it cleaner. And then they'll dump stuff back into the river, and they want to make sure that what they're dumping is also fairly clean. So they will also test their wastewater samples on a TOC analyzer to ensure that they're not in violation of anything at all. Okay. TOC determination in surface water and groundwater. We can also detect it in seawater. Determination in solid samples like soil using a suspension method. So it doesn't have to be a liquid, but eventually it does get turned into a liquid before it gets ran onto the machine. 1.6, determination of particles containing sample like cellulose test. And then 1.7, determination of particulate organic after filtration. So this is maybe helping prove that something like a glass fiber filter is working for you, or a filtration process is actually removing what it's supposed to be removing. So, for instance, you would check the water or the sample before filtration, and then you'll check it after filtration, and you'll compare the two and see if that filter did its job accordingly, right? So, all of that is going to be the environmental industry. So, if you want to work for an environmental company, there you go. There's kind of a handful, really, not the only thing, but a handful of things that you could do with the TOC analyzer. Next would be the pharmaceutical industry. If you work for pharmaceutical industry, you are either testing the products that they're making or you are part of the manufacturing process. And both of those things require very clean, ultra pure, what we call it, water. So if you look at 2.1, it's TOC in ultra pure water. 2.2 is a cleaning validations for final rinse. 2.3 is a cleaning validation for the swab method. 2.4 is your TOC determination according to what we call EP 2244. So EP is going to be a pharmacopoeia, and you've learned about pharmacopoeias now in this semester. And the United States has their pharmacopoeia, USP. That's why the US is there in front. But we've also discussed a little bit about these other countries that also have their own pharmacopoeias as well. All right, so what you're seeing here is that water is used in the pharmaceutical industry. And that water is either used in the manufacturing of that pharmaceutical product, or it's used in the cleaning up of that pharmaceutical product, or it's used in the testing of that pharmaceutical product. And in all realms, that water has to be extremely clean. So I can't make aspirin and make it in dirty filth water and then recover the aspirin and form into a tablet and give it to you to take, right? So part of this whole concept is that the water that you are using in all parts that touches everything around the pharmaceutical industry, that has to be tested, and it has to be super, super clean. And we call that ultra pure water mainly. So for that reason, you often see pharmaceutical companies have TOC instruments, and they are reporting values on their water that they are using throughout the entire process and any process that might be out there. Number 3, you're going to concern the chemical industry. And the chemical industry is basically chemicals, right? Maybe I'm working for a company and maybe their whole concept is making sulfuric acid. I mean, who knows, right? We've got a company kind of like that here in Wilmington. It's called Elementus Chromium. So if I am in the chemical industry and I am looking for these types of materials, or I'm using these types of materials, I want to make sure that they are perfectly clean as well. So I should not see any organic carbon in my hydrochloric acid or my nitric acid or my sulfuric acid or my sodium hydroxide solution. I shouldn't be seeing any remnants of dirtiness or filthiness that's left over in those products. So the TOC analyzer, again, does a very good job to do that for me. So I will take hydrochloric acid, I'll process that sample, I'll inject that sample onto a TOC instrument, and I'll measure it just like I measure maybe a drinking water sample. So again, no difference here, but a TOC is going to give me some idea about how clean my products or my solutions or my reagents are. So again, it is found and used in multiple different industries. These are only 3 examples, folks. That's it. But if it has a laboratory and it's making a product, and that product, we want to ensure that it is clean before we sell it to somebody else, then a TOC analyzer is going to probably play a role in some form or in some fashion. Okay, overall scheme of TOC. The overall scheme you're going to see in a box diagram here on your screen, and it's based off of this combustion reaction. Now, I'm going to talk about that in just a second, but combustion reactions are typically something that you learned about in Chemistry 151 or 152, and we'll review it just to kind of go back and jar your memory. And for those of you that have not taken Chemistry 151 or 152 yet, good news, we're going to treat it like you've not seen it before, so that way you know what it is coming into this. Overall, though, what happens is that take a sample, and this sample is mixed with a little bit of acid, and that goes through what we call a sparging process. And this sparging process, it's pretty important to happen below a 3, which is why we add the acid. And after the sparging, then we are going to mix that sample with some purified air, and a combustion reaction is going to happen, making CO2. And then CO2 is going to be released, and it's going to be seen by the detector. All right? So overall, this is what's happening on the inside of the machine. I'll take a sample in, mix it with some acid, sparge it, mix it with some air, allow it to combust, and then have that product, carbon dioxide, to go into a NDIR detector, or simply something that sees the CO2, the detection. That's what we're after. All right. So a little bit about the combustion. So let me clear the screen out so you can follow me. A combustion reaction is typically one of these 5 reactions that they normally present to you in a Chemistry 151 class. All right, so combustion is basically an organic molecule, and I'm going to add O2 to it, and every single time I produce CO2 and water as a product. And that's the only products here, folks. That's all that there is. That's it. Nothing more to it than that. That is a combustion reaction. Now, the organic molecules, it can be a number of different things, all right, as long as it's classified as organic. So, for instance, C6H12O6. I talked about that a few slides back, right? So this is glucose. I can take glucose and add oxygen to it, and I can make CO2 and H2O. All right, so for instance, I can take blood sugar, glucose, I can add the oxygen that I breathe in, my body will combust those two products, and what I pump out of my mouth will be CO2, carbon dioxide, right? I'm breathing out carbon dioxide. Well, that carbon dioxide would be taken up by plants. So, folks, CO2 is not necessarily too bad because all plants have to have it. That's their food source. So they can take that CO2 up, and then they can also process it and metabolize it, and they pump out O2. And that O2 is what I need to breathe in order for me to live. But CO2 is an integral part of that. So this is a reaction, and it's a combustion reaction. Now, it's not balanced, and I'm never going to ask you to balance a combustion reaction. That's something that I'm not going to do, right? They can take care of that in 151 and 152. But bottom line, every single time a combustion reaction happens, every time, CO2 and water will be made. Nothing else. That's it. 2 products. It doesn't matter what type of organic that you're starting with. 2 products. CO2 and H2O. So we get a machine. And this machine is developed. And this machine understands this concept. And it says, all right, if you have a sample of something, and that sample gets injected onto the TOC instrument, that sample could have organic type of material in it. And that organic type of material that's not purgeable, NPOC, will stay in that water sample. And we just simply have to mix it with some O2. And if we have an eyeball over here that is designed to only look for CO2 and that is it, then my machine will be able to tell me how much non-purgeable organic carbon there is in the sample based on the amount of CO2 that it sees in the sample. If I have a lot of CO2 here, I'm going to have a lot of NPOC here. That's what makes the CO2, folks. Of course, if I do not have a lot of CO2, then that means my sample probably does not have any or very few non-purgeable organic carbon molecules. So overall, this is the TOC, and that is a combustion reaction. An organic mixed with oxygen gives me CO2 and water. Now, a couple of things here that I want to go ahead and mention and take care of. Number one, O2. Where on earth do I get O2? Because it looks like this has to be included for this reaction to happen, right? Number two, what about the water? Where does it go, right? I mean, if it's going to be made, then where on earth does it go in the machine? So we need to talk about that eventually. We need to talk about that water and where does it go. We need to talk about the O2, where does it come from? And there's something else that this equation is leaving out, and that's what we call a catalyst. And a catalyst normally is written above the arrow, and here I'm going to draw a triangle. And that triangle means heat. Most of the time, especially in a laboratory field, the triangle is going to mean heat. I'm going to have to put heat into the system in order to get it go forward. If not, I'm going to be here forever. Okay? So this organic molecule mixed with O2 and some heat will give me CO2 and water. And this detector and this instrument will measure that CO2 that's getting pumped off. And the higher level of CO2, the more contamination that I have. All right, in a nutshell, that is what the TOC analyzer is doing. But we need to go specific. We need to go nitty-gritty pieces and parts. And that's going to be the purpose of the upcoming videos. What are the pieces and parts that make this work? What are some of the things that you should know as an analyst working in a laboratory to take away just in case you are placed on a TOC instrument at one point in time? All right, so that's where this next video is going to start. So come back and see me. Don't be gone too long.